Hey everyone, welcome to the Seneca OOP 244 Workshop 4 Lab Walkthrough for the fall. Let's take a quick look at this workshop. We'll be going over constructors, deconstructors, and the current object in a class. So if we scroll down, there are these rules that they created for us just below Lab 1 here. Adding to the content of a canister, and then there's also pouring contents of one canister into another. So let's quickly read these rules and see what we need to do. So you can pour contents into the canister as per their label. If too much is poured into a canister, causing it to overflow, the canister is rendered unsaleable. Pouring contents of one canister into another. You can pour all or some of the contents from one canister into another. If this results in mixed contents, for example, the labels are not the same, canister will be rendered unusable. For example, you can fill an empty canister with no content name with the content of a canister holding olive oil. Since the target canister was empty, everything will be fine and the canister will be labeled as olive oil. However, if the canister was labeled as orange juice, whether it was empty or not, this is important right here, whether it was empty or not, it would be rendered unusable. An unusable container cannot be used or cleared to become usable. Okay, and then we also need to manage all of our memory leaks, so we got to keep that in mind as well. So in this lab, they fully create the CSTR class for you, and there's a bunch of functionality inside of here. So actually, let's take a quick pause and create the projects. Let's do a new project. We'll do a empty project next, and we'll call this Seneca Lab 4 2024. And let's click create. Okay, so now let's go ahead and create all the classes we need to create here. So let's start with this one since it's going to be fully implemented for us. So let's right click on here, add a class, and we're going to add CSTR. It'll create the header and the source file for us. So let's copy the contents of the header file, paste it inside of here. Oh, we can close this. Yeah, paste it inside of here. And then let's go inside our source file and find the source file, which is right here. And we will copy it, Control A, Control V, paste it in. Cool. And now let's create our other file. So let's create the canister class as well. Canister. Okay. All right, let's start with the C file. Let's copy it, go into the C file, paste it, and then let's go back to the source file. One thing to note is that all of our private functions, they already wrote the code for us. So all what we need to worry about is a few public members and then the constructors and deconstructors. So they make it a little easy for us in this workshop. Okay, there we go. And then let's go back and get our, where is it? Our main. And here's where all the tests are going to be run and all the output. So let's copy it and let's create a new item. We'll call this our main and just Control V, paste it in. Awesome. Okay. So now let's go over to our canister.h. And we're going to be defining a bunch of public functions now. So let's go back to the lab or the instructions here. Let's scroll down to where it says. One more thing is that we also need to read this and figure out what our limitations are. So two main things we got to take from here. So firstly is any container filled higher than 0.267 centimeters from the top of the canister is considered unusable. And then the smallest canister can have dimensions of 10 centimeters in height and diameter, while the largest canister can be 40 centimeters in height and 30 centimeters in diameter. So we got to remember these when we write our constructors to make all of our constructors down here for default values. Here we have three constructors, so we're going to have a default constructor, and this is going to create a canister with these dimensions, so 13 as the height, 10 as the diameter, volume is 0, and a null name. Here we'll be able to set the name only and then these values. And then here we have height, diameter, and content name. And if the name's not provided, it should be defaulted to null pointer. Okay, so let's go down and let's find the actual instructions Here are all of our variables. Here are the functions that are already created for us. So let's start off with our default constructor and our one argument constructor and then our three argument constructor. So let's go right here, below public. We want our constructors to be public so people can access them outside of the class. So we're going to do constructors, and then let's write out the three constructors we need. So we're going to have a canister. So this will be our default constructor. This one is the default because there are no arguments. Then we're going to do canister that just takes in the name, so the one argument constructor. So we'll take in a const char pointer and we'll call this content name. And then our three argument constructor, so we'll do this again, canister. And then we're going to take in first a double, and this will be our height. We'll take in another double. This will be our diameter. And then lastly, we'll take in our name, and we want to have a default name of null pointer in case I don't add one. So we can give our constructor here, or our last argument, a default value of null pointer by doing this. So we do content name. This is just the normal argument, and then to add the default value at the end, you just do equals and then null pointer. So we can make this whatever we want, but the assignment specifically says make it a null pointer. Let me just close this a little bit. Yeah, so now let's go ahead and make our three constructors. So this is the first one. So you can just click the screwdriver here and then click define in canister.cpp, and it'll go here and create it for us. So for this first canister, remember we're going to want to set all of the default values. So first, let's do the name. So the name of a class here, if we scroll up, we can see all the values right here. So we're going to do m underscore content name. This is going to be equal to a null pointer. And then we're going to do the diameter. So the diameter needs to be a default of 10. So underscore diameter is equal to 10. And then the height is going to be a default of 13, like from what we read before. So height is equal to 13. And then lastly, the volume, we're going to default this to 0. Content volume is equal to 0. And that's all what we need to do for our default constructor. So let's go back now and let's write the code for our one argument constructor. We are going to first set the name, and there's actually a method inside of here called allocopy, which dynamically copies the name from the source to a destination. So when you have a minute, read through all of these. They're just functions to help us manage our char pointers and our strings. So let's go back and we could use this allocopy function here. So we're going to write allocopy CPY, and the destination, which means what we're going to save into. We're going to save into content name, our class's name, and then we're going to pass in the content name to copy from. And then again, we're going to want to get the diameter, height, and content volume as well. So we'll get these, paste it in, and then this should be done for our one argument constructor. Next, let's do our three argument constructor. So again, click the screwdriver, click create definition of canister. So first thing we could do is actually just set the height and diameter. So height is equal to height, and then diameter is equal to diameter, and then the volume, content volume, is going to be equal to 0. Okay, so we have this name now, and we know it's going to be defaulted to null. And if it's not defaulted to null, we're going to use the value inside of it. So we can actually just use the allocopy function again, because if we go to the definition of it, wherever it is, the source, it's going to say if source basically is not null here, it's going to copy it, else nothing basically. So this returns a boolean, but we don't really need the boolean. We can default our name to be set to a null pointer and then just call allocopy. And allocopy will take care of the logic for checking if it's null or not. So if it's not null, it'll set the name. If it is null, it just doesn't do anything. What we can do here is just m underscore content name. Make this equal to null pointer. And then what we can do is just check if the canister is usable. So usable. And then if it is usable, we're just going to set allocopy. And here we're going to pass in m underscore content name, and then the content name coming in. So now that we have our three constructors completed, let's carry on to some of the public functions we need to write now. So Let's scroll down here, and here are our constructors. And by the way, the reason why I knew to do this is because here it says if the object is usable, use the private method. It dynamically allocates and copies the content name into memory pointed to by m underscore content name using allo copies. And then, yeah, let's do our deconstructor actually. So here it just says deallocate the dynamic memory pointed to by the content name attribute use free mem. So pretty much we only have one piece of dynamic memory here, and it's our content name because it's a pointer. Pointers are dynamic memory. So right here, let's go ahead and type out the deconstructor. So for the deconstructor, we're going to write a tilde and then just the name of the class, so canister again, and then empty arguments here. So this is the deconstructor. So whenever our object is being destroyed, the class knows to call this specific function to basically remove all of our dynamic memory, but only if we have it. So we'll call this destructor, and then we will create the definition. So all what we need to do here is call free mem, and then pass in our m name, so m underscore content name. Now our deconstructor is done. Now let's go back and let's write out our other functions we need to write. So we have our public methods for our member functions. So we have a clear, set content, pour, second pour, that's going to be overloaded, and that's it. And then our display here is already written for us. So let's go up to the top, and let's start off by writing our clear prototype. So let's go to, yeah, we're already inside our H file. I'm just going to put a comma here to say helper funcs for all of our helper utility functions. Okay, so the first thing is our clear method. So this receives nothing, and it returns the reference to the current canister object. Okay, so it returns a reference to the current canister object. So we want this to return a reference to a canister, and then we'll just pass in like its own object. To make that the proper return type, we just call canister and then ampersand for the reference, and we'll call it clear. And this takes no parameters. So now let's click over it and click the screwdriver, click create definition in here. Awesome. So now let's write the code for this. Let's read what we need to do. So this clears a canister back to an empty state by deallocating the memory pointed to by the content name attribute, see the free mem function, and then setting the content volume attribute to 0. At the end, it returns the reference to the current object. So all we need to do is we first need to check if it's usable, and that's because if we go back up here to where these rules were, so for right here it says an unusable canister cannot be used or cleaned to become usable. So we need to prevent it from being cleared if it's not usable. So the first thing we gotta check is if it's usable, and to do that, we could just call that handy usable function that was already implemented for us. So we could say, if it's usable, we want to clear out the name and then set the volume to 0. So we can do free mem and then pass in our name here. So m underscore content name. And then we want to set the volume to 0. So volume is equal to 0. And at the very end, we want to return a reference to the current object. So to do that, you just do return star this. Okay, so now that clear is completed, let's go ahead and write the prototype for set content. So let's go below here and let's see what we need. So this is going to receive a const char pointer to content name, and then it's going to return a reference to the current canister object. Okay, so let's write out the prototype for this. So again, it's going to take in a reference to the current object, and then we're going to call this set content, and then it's going to take in a const char pointer called content name. Okay, so that's our prototype. Now let's write the actual code for this. Okay, so if the received name is not null and the canister is usable, it will set the content name of the canister only if the canister does not have a name, so if it's null pointer, or it is empty. Otherwise, if the canister already has a name and it does not match the received name, the canister will be rendered unusable. The function will do nothing if the names are the same at the end the method will return the reference to the current object. Okay, so all what this is doing pretty much is just setting the name of the current canister. So first thing we're going to do is say if content name is not equal to null pointer, and if our current container is usable, then we're going to want to do one of two scenarios. So the first scenario is if our current name, so m underscore content name, is equal to null pointer, or if is empty. So this is going to check if our current canister is empty or not. Then what we're going to do is we will allo copy, and we will set our name, so content name, and pass in the incoming name, so content name. Else if, so here we're going to want to use our helper function up here called has some content. So this is going to return true if we have a name, and if the incoming name is true, and if these names are also the same. So we're going to see if it's not the same, we're going to make it unusable because you can't mix two different containers if they're not the same. If it's not null and they're not the same, then we're going to make it unusable. So to do this, we're just going to say has same content. So we're going to check if it's the same content here, and we're going to pass in canister. So we'll create a new canister, and we're going to pass in the incoming content name. And we want to see if this is equal to false. So this returns a true if they're the same, and then false if they're not the same. So we're going to put an exclamation mark to turn that false into a true. And if it is true, this will return false. So this just does the opposite of what whatever this returns us. So if they're not the same now, because adding the exclamation mark means not. So if they're not the same, we're just going to set to unusable. So we're going to set our current container to an unusable object. And then at the very end, so to return a reference to the current object, we're just going to return star this. This will get the address of our current object. And yeah, that's all we need to do for the set content function. So the next thing we need to do is our pour method. So we have two different pour methods here. Let's write them both out. Okay, so the first pour method is going to take in a double quantity as a parameter, and it's going to return, again, a reference to the current object. And then down here, this is going to receive now a different canister to, I guess, pour one canister into another. And then again, it's going to return a reference to the current object. So let's write them both out right now. So we'll do canister reference, and this is going to be called pour. And this one's going to take in a double quantity. So we'll just call it, yeah, like, let's just copy what they have here. So they want quantity. And then that's all we need for that line. And then we can just copy this because it's going to be the same function, but we just need to overload this with a different parameter. So for the second one, this argument is going to be a reference to an incoming canister. So this allows us to mix one canister with another by accepting a reference to a canister. So let's first write our double quantity canister, the one that takes in a double. This one's a little bit more simple. If the canister is usable, it adds the quantity argument to the content volume of the canister if the quantity fits in the canister. Otherwise, it will render the canister unusable. In any case, it will return the reference to the current object. So, logic to use. So use the usable volume, capacity, and set to unusable methods in this logic. So if the canister is usable, let's start with that. If usable, since that's our helper function, we have to check if our current canister is usable or not. And then if the quantity is positive, so let's check if our quantity is positive. So if quantity is greater than 0, because that's how you check if it's positive or not. And and the sum of the quantity and the current volume is less than the capacity. So we need to do the sum of the quantity and the current volume, and we need to check that's less than the current capacity. Let's put a pair of brackets here to do their math in, and we're going to do, well, m underscore content volume plus the incoming quantity. So if this is less than or equal to our capacity, then we're going to want to add the incoming quantity to our volume, m underscore content volume, and we're going to add the quantity to our volume. So plus equals quantity. Or otherwise, render the canister unusable. So we'll just use that set to unusable function. So here we'll just call set to unusable. Regardless, we're always going to return a reference to the current object. So down here, we will then return star this to return a reference to our current object. Now that we did our first pour method, let's do our second pour method. So let's go back in here. Let's get the prototype, create the definition, let's clean it up. Awesome. Okay, so let's read the logic for our second one. So this function pours the content of the canister argument into the current canister following the specs at the top. Yeah, so we need to just read these again if you don't remember them. So let's go back down to where we just were. They want us to use the usable, volume, capacity, pour, double, and set contents in this logic. So it looks like we'll be using this to pour the content once we figure out if we can actually use it or not. So first thing we're going to want to do is check if the canister is usable. So we're going to say if our canister is usable. You know, just for fun, let's also check if our incoming canister is usable as well. So we'll do and if our can dot is usable, usable, then we will continue on with the code. If the volume of the canister argument is more than the capacity minus volume of the current canister, so we need to get that math. So we'll just do, I guess, figure out the available capacity left. So we'll call this available is equal to capacity minus volume. And let's just check if this available volume is greater than 0. So available is greater than 0. So we want to say the content volume of the canister argument will be reduced by the capacity minus volume of the current canister. Oh yeah, sorry, we got to check also this as well. So now we need to check if the can dot m underscore content volume, because we're going to be pouring in everything from this can into our can unless it overflows. And then we're going to do, while this is greater than the available room, then this means that we can fit all the liquid inside. So what we'll do here is can dot m underscore content volume, so our incoming parameter, we're going to subtract whatever available room we have, so available. And then we're going to pour that into our canister. So we already know what we just subtracted because we have it stored in available. So let's call pour and pass in available. And this will now take out whatever we just put inside of here. And then we'll write else. So here we're going to pour whatever we have available. And then here we're basically going to pour the entire thing inside of our container because that means it fits. That means we're going to do pour, and we're going to pour the can dot m underscore volume. So we're going to pour the whole volume in and then pour. And then we're just going to set the volume of the incoming can to 0 because we just poured the entire thing into our current canister. And then at the end here, we're just going to set the content of our current canister to the incoming canister. And then this will also handle if we pour the wrong content inside of here or not. So we'll do set content. We'll do can dot m underscore content name. And then at the very end, we will then return a reference to the current object. And that should be all the code. So let's go ahead and run this, and let's see that this is correct. So I'm going to go over to the output that they provide to us. So lab, let's do correct output. Let's run this, and let's see if it's what we want. So it ran, but nothing quite happened. Let's see where our bug is. I'm going to put a debugger line right here. Let's just run as the debugger to see what went wrong. Okay, so let's step into our constructor here. Let's see what's happening. Okay, so it looks like we are going to be setting the name. which we do. Okay. It's running all these lines. It's going to copy the length, copy it, do all of this, step out once. Okay, so it's going to set the name, set. Oh, we have an error here. Okay, so thrown exception. So I think we're getting an error thrown on this second line here when we just do the name, I think. So let's run it again. Let's stop it. Let's do just F5. F5 runs the debugger. So we'll stop here. Let's step into it and let's see what's going on here. So we're calling content name here with diameter 13. Let's just skip over it. Are we going to get... Okay, so we get the error right there. Let's go back and take a look at it. Oh, you know what's wrong here? The reason why we're getting this error is because we didn't set this to a null pointer. This is not set to anything, so that's what's going to be causing the issue. So instead, we'll just do content name is equal to null pointer, and this should actually clear up the issue we were getting before. So let's actually just run this normally without the debugger this time. So I'm going to press Control F5, or I need to stop the debugger, and let's press Control F5. Okay, so here we go. This is our output. Let's compare it to what the correct output's supposed to be. Let's go up to the top. Let's go up to the top here. Okay, so we have olive oil, 1549.8. Okay, orange juice. These four are sanitized and empty. Yep, these four are 1, 2, 3, 4, sanitized and empty, and then 1, 2, 3, 4 recycle. 1, 2, 3, 4 recycled. Okay, let's scroll down. The 1, 2, 3, 4, 5, 6 are sanitized. 1, 2, 3, 4, 5, 6 are sanitized. We have 4 recycled here, 4 recycled here. And then let's go down to the milk. Milk is 1200, milk 100, milk 1200, 100. Olive oil 20,000, olive oil 20,000. Orange juice 500, orange juice 500, and then an empty one, and an empty one. Okay, so we're going to empty a milk canister into another. So it looks like that worked. We're going to do the orange juice. Looks like that worked. We're going to make one unusable. Looks like that worked as well. Then we have 2400, 2400. Okay, unusable recycled, unusable recycled. 2999.9, 22999.9. Olive oil looks like it worked. And then the last two, this is going to be unusable with negative values. And then this is going to be olive oil and olive oil. Awesome. Okay, let's go to the bottom. So we should have 1, 2, and 3. 1, 2, and 3 all unusable. So 1300, 21,099, and then 100, and then unusable. Okay, awesome. Looks like it works. Now let's also run this in Valgrind and make sure we have no memory leaks as well. So I'm going to close this. I'm going to right click here. I'm going to do open in terminal. Okay, so I'm going to do, let's close this, just to give us more room. So I'm going to type out WSL -- set default to Ubuntu. Not sure why I went around, but operation was successful. So I'm going to do WSL to go into my Ubuntu interface. Okay, awesome. So now what we got to do is we'll run sudo apt update. I got to enter my password here. Okay, this is going to download for a minute. While this downloads, let's go over here to find the execution line we need. So to run this inside of your matrix, you shouldn't need all of these commands. I think the only thing you need is this, and just to write in the files that you have. So I'm going to do Control L to clear out the console a little bit. So let's write out that command. So G++ dash capital W wall dash std is equal to C++ 11, then dash G dash O, we'll call it WS for workshop, and then all of our files. Canister file, canister.cpp, and then we're going to have our cstr.cpp, and then main, and now let's compile it. Looks like it compiled successfully. So let's run it one more time just to make sure it works. So we're going to do /ws to call our executable. Okay, let's just look at the bottom. I think that worked. And now lastly, let's run the valgrind command to make sure this still works. So I'm just going to copy it. Let's right click inside of here to paste it. And then I think we just need to ./ws for it to run. And hopefully we get no memory leaks. It's running, and 14 allocated, 14 free. All heap blocks were free, no memory leaks. Perfect. So it looks like this works. Hopefully this helped you and you're able to submit your labs. Thanks for watching, and I'll see you in Workshop 5.